All right, now push has finally come to shove, and we are going to construct a 95% confidence interval for the average of all reported pickpocket losses in dollars. We're going to show the formula, the substitution, and the final result using the calculator. All right, so if that's the case, don't forget the formula. We saw it on the previous page, but it's also in your inferential statistics info sheet right here. Remember that neon green packet in your course pack is your Bible for the rest of this course. You want to have it on you at all times. You want to refer to it at all times. All right, so we have x bar plus or minus t alpha over 2 s over the square root of n. So I'm going to need some values here. All right, so let me grab the calculator. If you remember, we ran one variable stats already. So you can see x bar is 513.32, and we need s because that's our sample standard deviation, which is 262.23. So I'm going to plug in those values right there. So this is 513.32, and then s was 262.23. And if there's one thing you should know at this point, it's what S is. It's the sample standard deviation. And then N, remember, was 25. It tells us so right here in case you lost track. N is 25, sample size. So that leaves us finding T. All right, well, let's go figure out some stuff. Since our 95% is our confidence level, C level is 95%. That means that alpha is the complement of that, which is 0.05. That means that alpha over 2 is 0.025. This will be the column of the t-table, if you're going to use the t-table. Now your degrees of freedom is n minus 1, which is 25 minus 1, which is 24. That's the row of your t-table. And luckily for you, this one's in the table. Or you could use your calculator. Either way, doesn't really matter. Okay, so then t, I need t 0.025, comma, and my degrees of freedom was 24. To find that, I would use inverse t. And remember, t doesn't use 0.025, it uses 0.975, it uses the complement because it always wants the area in the left tail. This is the area in the right tail over here. So I use the area in the left tail for inverse t, comma 24. Well, it doesn't really matter that much because if you use 0.025, you're just going to get the negative value, that's all. And we just want the positive one. Okay, so let me grab my calculator. I'm going to go to distributions, pick number 4, inverse t, 0.975, 24, paste, enter, and I get 2.064. Now let's see if it's the same in the table. So, which I imagine it is. So I want to go to the row 24 and I want to go to the 0.025 column. That's kind of right under the word area. So you take the 0.025 column, your 0.025 column, and you want to scroll down to where it's 2.064. That's the 24 row. See, same in the table as it is in the calculator. So use whichever way you like. It doesn't really matter to me. Okay, so that means that t is 2.064. Right, oops, I don't want to box that technically because that's not an answer. That's just a aside. So that tells me that I need to put 2.064 in here. Okay, this is kind of side work over here. All right, then, now that I know that, I could try to type all that into a calculator, but let's face it, I'm probably likely to mess it up or do something wrong. And why not use the power of the calculator after all? So let's go to Stat, let's go to Tests, and then look through the list. And if you remember on your inferential statistics info sheet, I tell you right here which one to use. If you're using this formula, then you should be using t interval. So look through the list for t interval, and you'll see it at number 8, t interval. See right there? So press 8. All right, now this is choice you're going to have to make a lot in these chapters from 9, 10, 11, 12. You have to decide, did I have data or do I have statistics? Now, if you select data, which I currently is selected, that's why it's dark. When I go to my notes, if I had a data set that I entered into L1, then I would say I have data. Oh, but I do. I entered this data set in L1, did I not? Therefore, I would select data for this one. So data is the one you choose when you have a data set, when you have a raw data set. So L1 was where my data was located. Frequency, we always leave at 1. Changing that is kind of a more advanced option that we don't work with in this course. And my confidence level was 0.95, if I'm not mistaken. I just want to make sure of that. Yeah, 0.95, 95%. Okay, so I'm going to choose 95%, 0.95, go down to calculate, press enter, and there it is. And I'm going to show you a little trick. You never actually had to run one variable stats because running this t interval tells you x bar, s, and n right there. All the pieces you need for the formula, with the exception of the t value, are given to you by the calculator. So all you have to do is write it up, 405.08 and 621.56. So that's my results. 405.08, 08, comma, 621.56, and you got it. And the calculator finds this number, and this number for you when you run t-interval. The only one that doesn't find is the one from the t-table or inverse t, which is 2.064. Now, what does this mean for pickpocketing offenses? What do we think? We are 95% confident. Delete that. We are 95% confident that the true average amount taken from all reported pickpocket offenses. Ooh, pickpocket, not pickpocket, pickpocket offenses. All of this, everything I just wrote, the true average, blah, 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 all of that is just to explain mu. Remember, you're making a confidence interval for mu. Everything that I just wrote there in English, all that phrasing, all of that is just to explain what mu is. Mu is the true average amount of pickpocketing offenses. That's it, right? For all reported pickpocket offenses. Is between, oops, I have too many E's there, is between $405.08 and $621.56. We have units on this one because this is talking about money. So we're going to use the dollar symbol for that. Wonderful. Now, if we lowered our confidence level, leaving everything else the same, how would the interval change? So let's think about the interval for a second. The interval is built from this formula right here. Okay. Now we had a t value built from 95%, right? So let me put it this way. Let me do the error here. Okay. The error is equal to t alpha over 2 times s over the square root of n. That would be your margin of error. Okay. Now, if you leave everything the same, so when they say leave everything the same, that means leave your n the same, leave your s the same, leave your x bar the same, everything the same. So all of it the same. What is going to change if you lower your confidence level? Well, if you lower your confidence level, look at what's going to happen to your t-score. So you're at 24. You're at 0.025. If you lower your confidence, you're going to be lowering your t-value. Makes the t-value smaller. Like, for example, 90% confidence would be a 1.711. So that's going to make the t-value smaller, and that would make your error smaller overall. So lower the confidence. Let me put it this way. Lower confidence lowers the critical t-value which is T alpha over 2. Okay, that critical T value gets smaller. There we go. And that would cause the error to get smaller, the margin of error. To get smaller as well. Remember that we learned this before, but I'll say it again. Remember that confidence and error are directly related. If one goes up, the other goes up. If one goes down, the other goes down. They go together, hand in hand, like peas and carrots. Okay, so if you if you lower your confidence level, it's going to lowers the critical T value, and that will cause your margin of error to get smaller as well, which means the overall interval will shrink because the error is equal to half the width of the interval, right? So it's kind of drawing from what we learned back in section 9.1, that all of these things are kind of interconnected. So if you lower your margin of error, you lower your t-score. If you lower your t-score, if you lower your confidence level, you lower your t-score. If you lower your t-score, you lower your margin of error. And where the margin of error goes, so goes your width of your interval. All right, now a local law enforcement states that the amount of money for pickpocketing offenses locally is lower than the national average, with an average, or is no, lower than the national level, with an average of only 420. If this has come out as correct, does the local area appear to be different from the nation? So the local average is 420, and he's claiming that this is smaller than the national average. Now, does the interval support that claim or contradict it? Well, the interval is 405 to 621. So let me write that up. Wrong button. There we have it. So his claim is that 420 is smaller than the nation. That's the claim. Okay. So that 420, he's saying, oh, that 420, that's low. But the interval doesn't support that because the interval has 420 in it, right? So 420 isn't lower than the national average. The national average could be anywhere from 405 to 621. At least I'm 95% confident of that. And 420 is right in there. So he's not lower than the national average. The national average scoops down below 420. 420 is in the interval, within the interval limits. Now, if he had claimed that his area was the same as the national average, then the interval would have supported that because 420 is within that interval, right? It's all based on what they say and what they claim. Obviously, this is setting you up for chapter 10. Speaking of setting you up for something, last question. There had been 43 presidents of the United States. Their mean height is 70.8 inches with a standard deviation of 2.7 inches. Explain why these data should not be used to construct a confidence interval for the mean heights of the presidents. This is just a little thinking about it question that I kind of added in here. So throw it in there into your notes if it's not there already. And the thing about this is that we build confidence intervals when we have a sample because we can't get the whole population. But we actually have the whole population here because it's very small. It's only 43 presidents. I'll type that up 1 second. There, we only build confidence intervals when we're forced to use a sample to infer about a very large population. We actually have the entire population here of all 43 presidents, so it'd be inappropriate to make an interval as we already know everyone. In other words, there's no simple random sample here. If there's no simple random sample, you're not making a confidence interval. It's in fact a census of all the presidents. All right, so that was just kind of a broad strokes thinking about it question. I'll see you back here to talk about sample size and to review some more about confidence intervals.